All right, today we're going to do lesson 3.1. We're going to look at functions and relations. So somebody give me the definition of a function that you're not reading out of your notes. Someone explain to me what a function is. Trevin.
For every input, there's output.
Okay, for every input, there's exactly one output, which is the definition that we've written into our notes today. However, we've got to be able to understand what does that mean. So our essential question today is, what is a function? And that's what we're going to learn. Hopefully by the end of this lesson, the goal is to be able to tell what a function is, okay? Relations. Relations pairs inputs with outputs. Now, you have on your paper right now a good example of a relation. Can anybody look through their notes and see what a good example in your notes of a relation? If a relation pairs inputs and outputs, what's a good example? Deja? All right.
Input-output table?
An input-output table, very good, is a very good way to show a relation. All right, what about example 1, letter A? What are those called? Ordered pairs, very good. So those are relations, okay? Those pair inputs and outputs. But how do we tell if a relation is a function or not? And that's where the definition that Trevin gave us a few minutes ago comes in. For every input, so for every value we put into a problem, there can only be one output, okay? So for every input, there is exactly one output, if it's a function. Now, we also know, and hopefully this looks familiar, those values that we input into the problem are also called our domain. And those values that come out, the outputs, are called our range. All right, so we're going to talk about that when we get a little bit further in this lesson as well. But remember, if it's a function, for every input, there will be exactly one output. So in example 1, it says determine whether the relation is a function. So we know we have relations. All right, we've got ordered pairs, so we're pairing inputs and outputs. We have an input-output table. So again, we're pairing inputs and outputs. So what we're trying to figure out are these functions, okay? So here's the first thing I want you to write down in your notes. To determine whether the relation is a function, we're going to focus on x. Okay, we're going to focus on those x values. Because remember, for every input, there can only be one output. So let's start by looking at our inputs. Looking at letter A, we're given 4 ordered pairs. So Joshua Webster, what are the input values of those ordered pairs?
Number A.
Letter A.
-5, 0, 5, and 5.
Good. We have a -5, a 0, a 5, and a 5. Because remember, our input is our x values. Now, the question is, do any of those input values repeat? Yes. Which one is there twice?
5.
So, if one of our input values repeats, we have to actually stop and think for a minute. Let's look at the outputs. Okay, the first time they input a 5, what came out?
0.
A 0. And the second time they put the 5 in, what came out? 10. So, for every input, there is exactly one output. Is that true or false for this problem?
That's true.
For every, right, it's false, right? Because they input 5 and 2 different things came out. So is letter A a function or not?
No.
No, it is not. Okay? Not a function. So if we focus on those x values, if none of them repeated, we'd be in good shape. It'd be a function and we wouldn't really have to think anymore. But because we had an input that repeated, now we got to check those outputs. And the outputs are different. So there's not exactly one output for each input. So this is not a function. Now look at your table in letter B. Trevin, what are my input values? What are my x values?
2, 4, and 6.
All right. Does any input value repeat?
No.
So do I have a function?
Yes.
Yes, I do. So if none of my input values repeat, I really don't have to think anymore. It is a function. So focus on the input values. Any questions?
If none of your inputs repeat, it's a function.
Absolutely. If none of your input values repeat, you automatically know you have a function.
Can I put that in here and then
You sure can. All right, example number 2. Now this time they've given us a graph. All right, and we could sit here and we could find all of our ordered pairs on these graphs, and then we could compare all of our x values and all of our y values, but we don't have to do that. If we're trying to determine from a graph if we have a function, we're going to simply perform the vertical line test. How many of you remember the vertical line test? Okay, awesome. If a vertical line passes through a graph one time, the equation is a function. Now, just for sake of review, I like to teach as if you've forgotten everything. Vertical line, up and down, right or left. How do we draw a vertical line?
Up and down.
Up and down. So we are going to draw a vertical line. We can start it anywhere we want, but we've got to go through the graph. All right, I use a dotted line simply because I don't want to do a solid line and get confused over which one is my graph. So we're going to do a vertical line test. You can do it anywhere on the circle that you want. I'm going to start right here and I'm just going to work my way down. Now we're looking to see how many times that vertical line touches my graph. How many times does that vertical line go through that graph? Twice. So is it a function? No, because if a vertical line passes through a graph one time, it's a function. This is not a function because this vertical line passes through that circle twice. So not a function on letter A. All right, go ahead and do the vertical line test on letter B, and let's see what happens. All right, again, anywhere you want, you can start the vertical line anywhere you want. Noah, how many times does this vertical line pass through my graph? Once. So is letter B a function? Yes. It's also called a parabola, this graph, and we are going to learn how to graph parabolas. But the vertical line test, I could have done the vertical line over here. Okay, it only touches my graph one time. All right. Example number 3. Now, they want us to give the domain and the range. So let's review. You can look back in your notes if you need to. The domain is which value? X. Okay, our input is our domain. So let's make a little note. And our range is our what value? Our Y values. Okay, so for letter A, it should be really simple. Domain and range. We've got a set of ordered pairs. So picking out our domain and range should be really simple. Now, we'll put our domain and our range in order from least to greatest every single time, okay? So, Anthony, what is the domain for letter A?
1, 2,
Yep.
3,
Yep.
4,
Great. 1, 2, 3, 4, 5. The X values are 1, 2, 3, 4, and 5. All right? Timothy, what is my range? If my Y values are my range, what is my range? -2, 1, 6, 13. Perfect. And they're already in order from least to greatest. So if I'm given ordered pairs, domain and range is simple. I write down my X values for my domain, Y values for range. All right? But now we get a little bit tougher because now in letter B, we're looking at a graph. All right? However, this graph is made up of 4 points. So to make our lives simpler, we're just going to list in whatever order we want. We're going to give the 4 ordered pairs of those 4 points. Let's figure out the ordered pair for those 4 points. Now, just as a review, as if you have forgotten everything, okay? When you start in the middle of a coordinate plane, you're going right or left first for your X value, then you're going up and down for your Y value. So let's start with this point right here at the top. All right, what are the coordinates of that point? Trevin?
-2, 4.
Good. You go left to -2, and you have the ordered pair -2, 4. All right, what about this point right here? Alonzo?
-1, 2.
Left to -1, up to +2. Drew, what about that point right there?
1, 2.
Good. Right to +1, up to +2. And Deja, our last point right here is what? Okay, right to 2, up to 4. Perfect. Now, let's write domain and range, and let's list our domain and our range. Now that we've got our 4 ordered pairs, okay, the order of the ordered pairs doesn't matter. You could have found those coordinates in any order that you wanted to. But what is our domain? Michael?
-1, 1, -2, 2.
All right, let's do it from least to greatest. So it would be -2, -1, 1, and 2. And then what would our range be? Shonda?
2 and 4.
2 and 2 and 4 and 4. All right. So that one was a little bit more difficult, but not much, especially since you guys seem to know how to identify the coordinates of a point. So that's really good. Now, letter C is where it gets tricky, because letter C is a parabola, but it's a parabola that has an end. Okay, we're used to seeing a parabola that has arrows on the end, meaning it goes on and on and on and on, but this one actually comes to an end. This one has an end point here, and it has an end point here. Okay, and we are, for the sake of this problem and not getting super confusing, we're going to pretend that this parabola actually ends a little bit higher than it does. All right, we're going to pretend that it ends right here by -2. All right, and that'll be important here in a second. Now, let's go ahead and write down domain. And let's go ahead and write down range. And this one's going to be a little bit different, because so far A and B both had distinct coordinates, distinct points. This actually has a range of x values. So looking at the endpoints, all right, what is the furthest left that my graph actually goes? -2. Good. And what is the furthest right that my graph goes? Right here's the point. So it's lined up with 3. Okay, so my range, or my domain, goes from -2 to 3. All right, now watch. X is in the middle, -2 is to the left, and 3 is to the right. We are actually going to write a compound inequality for this domain and range. Now, we got to decide, are my x values greater than or equal to -2 or less than or equal to 2? So remember, my graph is going from here to here. So are my x values getting larger than -2 or smaller than -2? Larger. So x is greater than or equal to -2. But look at it from the 3. Are my x values getting smaller, less than 3, or greater than 3? Less than. So my symbol here is less than or equal to. All right, very good. Now, do you think you can do it with y? Remember, though, my y is up and down. Okay, my y values are up and down. So what is the lowest that my graph goes on the y-axis, and what is the highest? And then you can figure out your symbol. But again, y is going to be in the middle, because this is a compound inequality. So what is the lowest that my parabola goes? -2. And what is the highest that it goes? 4. Very good. Now, are my y values greater than -2 or less than -2? Greater than or equal to. And are my y values greater than 4 or less than 4? Less than. Again, because these are my y values from here all the way up to here, and then they stop. Okay? You guys got it? Awesome. All right, and that brings us to our last example. Now, this is something you probably have not learned before. All right, this is probably something that you have not learned before, so please stay with me. I'm going to try to make this as practical as I can. All right, first of all, I want us to focus on the function. The function is sorry about that. The function is our a equals -4b plus 14. Now, we're used to seeing something like this, y equals mx plus b, right? If I see that, so we're used to y equals mx plus b. If I were to show you y equals mx plus b, what is my input value?
Oh, I know.
No. Looking at x and y, what is my input value? All right, so if I'm looking at y equals mx plus b, x right here, this is my input value, all right? And when I put a value in there, I then multiply it by m, I add b to it, and that results in my output, or my y, okay? Everybody with me? Now let's go back to the function a equals -4b plus 14. Which of those variables would be where I'm going to input something? B is my input, so make that note, because this is going to be huge. If you can understand that B is your input, you're going to be in good shape. Once I plug a value in for B, now I'm going to multiply it by -4, and I'm going to add 14 to it, and my outcome is going to be what variable? My output is A. All right, so label that. All right. understanding what your input is versus what your output is going to be huge in you understanding what your independent variable is and what your dependent variable is. Now, let's talk about those words. If someone or something is independent, what does that mean? They're alone. It doesn't matter. They do whatever they want. All right? They act how they want. They do what they want. They're independent. They don't care what anybody else has to say or do. So, your independent variable represents your input values. That should be easy to remember, right? I and I. Your independent variable represents your input value. So that means my input, I can put in whatever I want. Okay, I can put in whatever number I want. But my dependent variable, what does it mean to be dependent on somebody?
You depend on them like you need.
Okay, you can't do something without them, right? Like if my attitude is dependent on my students, well, if you're really good, then I'm probably going to be really happy. But if you're really bad, I'm probably going to be really upset. Okay? So my attitude might be dependent on your behavior. All right? So the dependent variable is going to represent the output. All right? The output depends on what you've put in. Does that make sense to everybody?
Yes.
So if we're looking at this problem, it says the function a equals negative 4 times b plus 14 represents the number a of avocados you have left after making b batches of guacamole. So which one of those is our independent variable?
B.
All right, we've got some disagreement here. All right, if my independent variable represents my input value, go back to your function. A equals negative 4 times b plus 14. We already decided that b is where we're going to input stuff, right?
Yeah.
So what's my independent variable?
B.
What does b stand for?
Batches of guac.
Batches of guac. So we're just going to put IV, and our IV equals our batches. So that means I can make however many batches of guacamole that I want. But my dependent variable is what? My A or my avocados. Because it says A of avocados you have left. So depending on how many batches of guacamole I make. I can make however many batches of guacamole I want. But the number of avocados left depends on how many batches I've made. So my independent variable is my batches of guac. My dependent variable is my avocados. Any questions? Now, in letter 2, or I'm sorry, I keep saying letter 2 today. In number 2, it says the domain is 0, 1, 2, and 3. Domain is which set of values?
Your
Okay, my x. Okay, it's technically my x values. But in this particular problem, what variable is representing x?
B.
Okay, b. So we've got b is the domain. Okay, we're going to make ourselves a little chart. The function that we're dealing with is a equals negative 4 times b plus 14. And my output is what variable? In this problem, my output is a. Awesome. So they've given me the domain 0, 1, 2, and 3. They've given me my input values. They've given me my b values. 0, 1, 2, and 3. Now, I'm going to put each of those values into my function. So, I'm going to put a equals negative 4 times 0 plus 14. A is going to equal negative 4 times 1 plus 14. A is going to equal negative 4 times 2 plus 14. And A is going to equal negative 4 times 3 plus 14. So they've given me 4 different input values. So I'm going to put each input value into the problem. Now let's see what comes out. What is negative 4 times 0? Plus 14. 14. What's negative 4 times 1?
Negative 4.
Negative 4 plus 14.
10.
Now remember, this is how many avocados I have left, right? What's negative 4 times 2? Negative 8 plus 14.
6.
6. Negative 4 times 3. Negative 12 plus 14. 2. So once I've put in all of my domains, now what is my range? Because it says, what is the range?
2, 6, 10, and 14.
2, 6, 10, and 14. And again, least to greatest is what we're going to be looking for. So that is how you take a given domain, you plug it into your function, and you figure out your range. And that is lesson 3.1.